I got 271 over 300 in my A-level biology exam, and this is how I beat the examiner. Okay, a lot to get through today. So, first of all, when answering this question, we need to know what the respiratory minute ventilation is, and that's just the volume of air breathed in or out in a minute. Cool. Calculated by tidal volume times breathing rate. So what this question wants you to do is a description of what tidal volume is and what breathing rate is, right? So, on a spirometry trace, your tidal volume literally going to be difference in peak to trough volume, cool, and the breathing rate, number of peaks in a minute, multiply them together, those are your marks, cool. Oxygen consumption per minute, we are going to do an example of this, but what you want to do is find the difference between peaks, divide it by the time between the peaks, multiply by 60. Doesn't actually have to be subsequent actually, but you're finding the difference between peaks, dividing it by the time, and then multiplying by 60. We're going to see that soon. Cool. Here's a spirometry trace. I've annotated it because the question's coming up, but we know this is spirometry. V, you can see here, this person's just breathing at rest. You can kind of tell. Yeah, they're just breathing through the device. Cool. So that's going to be your tidal volume. Now let's look at these questions. So, which of the following is being written in breath per minute between 80 to 120 seconds? So, I've looked between 80 and 120 seconds. So you can see in your graph, x-axis, 80, 120. And I've counted how many peaks have I seen. I've seen 1, 2, 3, 4, 5, and 6. So I've got 6 breaths between 80 to 120. What does that mean? Well, I've got 6 breaths in 40 seconds. Divide it, so that's 0.15 breaths per second. Multiply by 60 to get minute, and got 9 breaths per minute, which is answer B. Then calculate the rate of oxygen uptake between 80 and 120 seconds. So I'm going to find the difference of the volume of air in the apparatus, because imagine your oxygen is going to be inhaled, so it's going to be gone. All right. So I look at the difference between 80 to 120 seconds. Yeah, 3.8 at 80, 3.15 at 120. So what I'm going to do is 3.8 take away 3.15. So we've lost 0.65 decimeters cubed of air. Cool. Divided by the time, so we're losing 0.1625 decimeters cubed per second. Multiplied it by 10 to the power of 3 because I want to change that to centimeter cubed. So we're losing 16.25 centimeters cubed per second. But I don't want it per second, I want it per minute. So I times by 60, I get 975. I really hope that explanation has made sense.